You're welcome. This is Solomon at Solo for Math. Today I want to look at further differentiation, and we look at other methods of differentiating functions. Today I want to look at what we call chain rule. The chain rule. When we use chain rule, when we are faced with a function, for example, y equals to x plus 4 squared, when we're told to differentiate such a function, someone would easily think about expanding this to give you x squared plus 8x plus a 4, which is okay, and then they go on to differentiate, giving you 2x plus 8. Consider using the method that we learned before. You can check for the previous lessons. If you factor out a 2, this gives you x plus a 4. Alright, now look at a case where you have a function like y equals to 3x plus 1 to power a 4. It would be okay if you could expand using this same method, but now this is a bit hectic and it takes a lot of time. And another thing, it is a bit wide. Okay, expanding to a power of 4, it may be a bit difficult and time consuming. Now this is when we bring in what we call the chain rule. Now for the chain rule, we introduce in a new variable. We let what is in the bracket, a function in the bracket, to be t in the brackets. Alright, so when you let it to be t, then it means your y will be a function of t. Your y will be a function of t. So it will give us the dy dt, and then your t will be a function of x. Remember, what is in the bracket is a function of x, so it will be a function of x, and this will give us a dt dx using the method of differentiation that we learned about. Now, giving us a chain rule method as dy dx, because we want dy dx equal to dy dt times dt dx. This is the formula that we are going to use for numbers which have powers, but we cannot easily expand them. For example, let's start with that same function. Differentiate y equals to x plus 4 squared. If we use chain rule, then we let what is in the bracket, which is x plus a 4, to be equal to t. Or you would write t equals to x plus 4. So on differentiating, let me write it the other way, x plus 4, we get dt dx, which is equal to, we know this is a 1 and this is a constant, it gives us a 0. Okay, now it means our y has become, when this is t, then our y has become t squared. So when you differentiate to get dy dt, this will be a 2t. You can go on and put in a t. What is a t? Our t, we let it to be x plus 4. So when we substitute in our formula, we say chain rule says that dy dx is equal to dy dt times dt dx. Then when we substitute, our dy dx would be equal to dy dt, which is this 2 into x plus a 4 times dt dx, which is a 1. and giving us a 2 into x plus 4, which we got even in the other method. If you expand, you get the same. So this was just to show you that you actually get the same answers. Let's look at other examples. Differentiate. Roman numeral 1. If you have 3x plus 1 to power 4. Roman numeral 2. If you have x squared plus 4x to power 7. Roman numeral 3. If you have 1 over x plus 2 and 4, we shall look at this 1 plus x squared. Alright, let's work out this. Roman numeral 1. We begin by letting y equal to 3x plus 1 power 4. Okay, another thing, we know our formula says dy dx equals to dy dt times dt dx. Now, it means we have to let something be a t, and we said that that is in the bracket. Let t is what we let to be t, which is 3x plus 1. So when we let t to be 3x plus 1, it means our y will be equal to t to power of 4. So when we differentiate the first one, this first equation here, let me call this the second. So when we differentiate the first one, we get dt dx as 3. Then when we differentiate the second one, we get dy dx, dt as the 4 comes down, t reduce the 4 by 1. It means that when we substitute back the x here, or the t, substitute for t, our t was 3x plus 1. Then there's a cube here. Alright, so it means now our dy dx equals to, we are substituting back here, dy dt, which is 4 into 3x plus 1 cubed into dt dx, which is a 3. And this one gives us a 12 into 3x plus 1 cubed. And that is it. Number 2. When we look at number 2, we still let our y to be equal to, it is x squared plus 4x to power 7. So it means after that we let also our t to be what is in the bracket. What is in the bracket is x squared plus 4x. So meaning our y would be equal to t to power 7. So from these two, the first one gives us dt dx, which is equal to the 2 drops, reduce the 2 by 1, giving you 2x, plus this will be a 4. When you go to this one, it will give us dy dt, which is equal to 7 dropping down, t to power 7 minus 1, which is a 6. Let's put in back the x here. T, we let it to be x squared plus 4x to power 6. Now our dy dx will be equal to 7. That is the dy dt, x squared plus 4x squared, power 6 times the dt dx, which is 2x plus a 4. And this one would be, if I factor out a 2 here, I'm seeing a 2 can come out here. It multiplies with this, giving me a 4 into x squared plus 4x to power 6 into this one remains x plus 2. And that is the answer. Looking at number 3, we have 1 over x plus 2, so we still let y to be equal to 1 over x plus 2. And we know we can rewrite this as y equals to, take this up. We want to write it in a way that we can easily use chain rule, and when we take it up, it becomes that. So we still let our t to be equal to what? What is in the bracket? Plus 2. And then it means our y would be equal to t to power -1. So get dy dt, get dt dx. So dy dt equals to, from this, the -1 drops, times t to power -2, which you can write as -1 over t squared, feed in the t, so it will be x plus 2 squared. Leave it there, get dt dx. Dt dx, from here, it will be a 1. So, meaning our dy dx will be equal to dy dt, which is -1 over x plus 2 squared times a 1, which remains -1 over x plus 2 squared. Yeah, that is it. Looking at another example, the last one, we have a square root of 1 plus x squared. So when we let our y to be equal to the square root of 1 plus x squared, then we know this one can be written as, when we have a square root, it is the same as power a half. So there is a half here. So we do the same. Let your t to be what is in the bracket, which is 1 plus x squared. And then it means your y would become t to power a half. So we get dy dt equals to a half drops, t to power a half minus 1 becomes negative a half. So this will be the same as like 1 over 2 t to power a half. When this t comes down, then the negative goes away, and this will remain as 1 over 2 square root of t. But what is t? Our t was 1 plus x squared. Good, we leave that there. So we get dt dx. What is dt dx from here? This is a constant, is a 0, then this one gives us a 2x. So our dy dx using chain rule, which is dy dt times dt dx. When we substitute, our dy dt is 1 over 2 square root of 1 plus x squared times 2x. Now the 2 can go, so that remain with x over the square root of 1 plus x squared. Yes, that is chain rule. Thank you for watching. Don't forget to subscribe, don't forget to share, and to like. If you have any question, just write it in the comment section. I shall be glad to work through it. See you.